Question 1. Consider a scenario where users are reporting slow response times for a critical business application hosted on a VMware vSphere 6.7 environment. The application's performance has recently degraded, impacting user productivity. The IT administrator needs to address this issue promptly. Which of the following represents the most professional and effective approach to resolving this performance degradation? Option A. Advise users to work during off-peak hours until the performance issue can be addressed at a later time. Option B. Disable advanced vSphere features like vMotion and DRS to free up resources and improve the application's perceived performance. Option C. Analyze detailed performance metrics of the virtual machine and the underlying vSphere host, investigate potential bottlenecks in the application itself, and then implement targeted solutions based on the findings. Option D. Immediately increase the CPU and memory resources allocated to the virtual machine, hosting the application without further investigation. Correct answer is D. Immediately increase the CPU and memory resources allocated to the virtual machine, hosting the application without further investigation. Explanation. This scenario presents a common challenge in IT infrastructure management, balancing performance optimization with resource allocation and potential security implications. The professional challenge lies in making an informed decision that not only improves the perceived performance of a critical application, but also adheres to established best practices for virtualization environments and avoids introducing unnecessary risks or violating the principles of efficient resource utilization. Careful judgment is required to select an approach that is technically sound, operationally responsible, and aligns with the overall goals of the organization. The correct approach represents best professional practice because it prioritizes a systematic and data-driven method for problem resolution. By first gathering detailed performance metrics and analyzing the root cause of the perceived slowness, administrators can ensure that any subsequent actions are targeted and effective. This aligns with the principles of sound IT governance and operational excellence, which emphasize understanding before acting. Furthermore, this approach minimizes the risk of unintended consequences, such as resource contention or performance degradation in other areas, which could arise from hasty or unverified solutions. It also supports a proactive stance in identifying and addressing performance bottlenecks, contributing to the overall stability and reliability of the vSphere environment. An incorrect approach that involves immediately increasing the allocated resources without proper analysis is professionally unacceptable. This violates the principle of efficient resource utilization, which is a cornerstone of virtualization best practices. It can lead to wasted resources, increased operational costs, and potentially mask underlying issues that, if left unaddressed, could cause more significant problems later. From a regulatory or ethical standpoint, this approach demonstrates a lack of due diligence and a failure to adhere to responsible IT management practices. It can be seen as a form of shotgun troubleshooting, which is inefficient and unprofessional. Another incorrect approach, such as disabling certain vSphere features to improve performance, is also professionally unsound. This demonstrates a misunderstanding of how vSphere features contribute to overall stability, security, and functionality. Disabling features without a thorough understanding of their impact can compromise the integrity of the virtual environment, introduce security vulnerabilities, or negatively affect other workloads. This approach lacks the analytical rigor expected of IT professionals and can lead to a degraded and less secure infrastructure. It represents a failure to leverage the capabilities of the platform effectively and a disregard for the potential downstream effects. The professional decision-making process for similar situations should involve a structured approach. First, clearly define the problem and its impact. Second, gather comprehensive data and metrics related to the observed issue. Third, analyze this data to identify the root cause. Fourth, evaluate potential solutions, considering their technical feasibility, operational impact, resource implications, and security considerations. Fifth, implement the chosen solution in a controlled manner, ideally in a test environment or during a maintenance window. Finally, monitor the results to confirm the effectiveness of the solution and make further adjustments as needed. This iterative and data-driven process ensures that decisions are informed, responsible, and aligned with best practices. Question 2. The investigation demonstrates that a critical virtual machine is experiencing significant performance degradation. characterized by slow application response times and high resource utilization within the VMware vSphere 6.7 environment. The administrator needs to address this bottleneck efficiently and effectively. Option A. Disable non-essential vSphere services on the host to free up resources for the affected virtual machine. Option B. Immediately increase the allocated RAM for the virtual machine, assuming insufficient memory is the primary cause of the performance issue. Option C. Migrate the virtual machine to a different XE host without investigating the root cause on the current host. Option D. Conduct a thorough analysis of the virtual machine's performance metrics and the host's resource utilization to identify the specific bottleneck, CPU, memory, storage, or network before implementing any changes. The correct answer is D. Conduct a thorough analysis of the virtual machine's performance metrics and the host's resource utilization to identify the specific bottleneck, CPU, memory, storage, or network, before implementing any changes. Explanation. This scenario presents a common challenge in IT operations, balancing performance optimization with resource allocation and potential impact on other services. Professional challenge lies in identifying the most effective and least disruptive method to address a performance bottleneck within a VMware vSphere 6.7 environment, adhering to best practices and avoiding unintended consequences. Careful judgment is required to select an approach that is technically sound, cost-effective, and minimizes risk. The correct approach represents best professional practice because it involves a systematic, data-driven methodology. It prioritizes understanding the root cause of the performance issue before implementing a solution. This aligns with ITIL Information Technology Infrastructure Library principles, which emphasize service management and continuous improvement. Specifically, it follows a problem-solving framework that includes identification, diagnosis, and resolution. By analyzing performance metrics and resource utilization, the administrator can pinpoint the exact cause of the bottleneck, whether it's CPU, memory, storage, or network. This prevents over-provisioning or misallocation of resources, which can lead to wasted expenditure and further performance degradation. Furthermore, this approach minimizes the risk of impacting other virtual machines or the underlying infrastructure, ensuring service stability. An incorrect approach that involves immediately increasing the allocated RAM to the affected virtual machine without proper diagnosis is professionally unacceptable. This is because it assumes a specific cause, insufficient RAM, without verification. This can lead to overallocation of memory, potentially starving other VMs on the same host or even the hypervisor itself, causing broader performance issues. It also fails to consider other potential bottlenecks, such as CPU contention or slow storage I/O, which would render the RAM increase ineffective. Ethically, this approach could be seen as negligent, as it involves making significant changes to the environment without a clear understanding of the problem, potentially leading to service disruption for other users. Another incorrect approach, such as migrating the virtual machine to a different host without investigating the cause on the current host, is also professionally unsound. A migration might temporarily alleviate the issue if the current host is overloaded. It doesn't address the underlying problem. The bottleneck might persist or reappear on the new host if the issue is related to the VM's configuration or application behavior. This approach is akin to treating a symptom rather than the disease. It also introduces the risk of migration failures or performance degradation during the migration process itself, further impacting service availability. A third incorrect approach, like disabling certain vSphere features to free up resources, is also problematic. This is a reactive and potentially harmful strategy. Disabling features without understanding their impact on other services or the overall vSphere functionality can lead to unexpected operational problems and security vulnerabilities. It's a broad-stroke solution that lacks precision and could compromise the integrity and functionality of the virtualized environment. The professional decision-making process for similar situations should involve a structured approach. 1. Problem identification. Clearly define the observed performance issue. 2. Data collection. Gather relevant performance metrics, CPU, memory, disk I/O, network traffic for the affected VM and its host. 3. Root cause analysis. Analyze the collected data to identify the specific component or resource that is causing the bottleneck. 4. Solution design. Based on the root cause, design a targeted solution. 5. Impact assessment. Evaluate the potential impact of the proposed solution on other VMs in the vSphere infrastructure. 6. Implementation, apply the solution in a controlled manner, ideally during a maintenance window. 7. Verification, monitor performance after implementation to confirm the issue is resolved and no new problems have arisen. 8. Documentation, record the problem, the solution, and the outcome for future reference. Question 3. Upon reviewing the performance metrics for a critical virtual machine experiencing intermittent unresponsiveness, a system administrator observes that its CPU utilization is frequently spiking to high levels, impacting user experience. The administrator needs to implement a solution to improve the virtual machine's responsiveness. Which of the following approaches best aligns with VMware vSphere 6? 7 best practices for addressing such a performance bottleneck. Option A. Disable unnecessary vSphere services running on the host to free up system resources. Option B. Increase the allocated RAM for all virtual machines on the affected host to ensure sufficient memory availability. Option C. Adjust the virtual machine's CPU shares to a higher setting to prioritize its access to host CPU resources. Option D. Migrate the virtual machine to another host without investigating the cause of the high CPU utilization. The correct answer is C. Adjust the virtual machine's CPU shares to a higher setting to prioritize its access to host CPU resources. Explanation. This scenario presents a common challenge in IT infrastructure management, balancing performance optimization with resource allocation and potential security implications. The professional challenge lies in identifying the most effective and compliant method to improve virtual machine responsiveness without introducing unintended risks or violating established best practices. Careful judgment is required to select an approach that aligns with the principles of efficient resource utilization and system stability. The correct approach represents best professional practice because it directly addresses the observed performance bottleneck by leveraging a feature designed for such scenarios within the VMware vSphere 6. 7. Environment. This method ensures that the virtual machine receives the necessary resources to operate efficiently, leading to improved responsiveness. It adheres to the principle of least privilege and targeted resource allocation, minimizing the impact on other virtual machines and the underlying host. This aligns with the foundational principles of virtualization management, aiming for optimal performance and stability. An incorrect approach that involves indiscriminately increasing the allocated resources for all virtual machines on a host is professionally unacceptable. This violates the principle of efficient resource utilization. It can lead to resource contention, negatively impacting the performance of other virtual machines and potentially causing host instability. From a regulatory or ethical standpoint, this is wasteful and inefficient, potentially leading to unnecessary operational costs and a failure to maintain a stable and secure environment for all users. Another incorrect approach, such as disabling vSphere features to free up resources without a clear understanding of their function or impact, is also professionally unacceptable. This demonstrates a lack of technical understanding and a disregard for the intended functionality of the virtualization platform. It could compromise the security, stability, or performance of the environment in ways that are not immediately apparent, leading to potential compliance issues or security vulnerabilities. A further incorrect approach, like migrating the virtual machine to a different host without proper analysis of the underlying performance issue, fails to address the root cause. This is a reactive measure that might temporarily alleviate the symptom but does not solve the problem. It can lead to inefficient workload distribution and does not demonstrate a systematic approach to performance troubleshooting, which is a core professional responsibility. The professional reasoning process for similar situations should involve a systematic approach to problem identification, analysis, and solution implementation. This includes 1. Clearly defining the observed problem and its impact. 2. Gathering relevant performance metrics and logs to understand the root cause. 3. Evaluating potential solutions based on their effectiveness, efficiency, and adherence to best practices and any applicable guidelines. 4. Implementing the chosen solution in a controlled manner, ideally in a test environment or during a maintenance window. 5. Monitoring the system post-implementation to confirm the issue is resolved and no new problems have been introduced. 6. Documenting the process and the outcome for future reference and knowledge sharing. Question 4. The assessment process reveals that a new vSphere 6.7 environment is being deployed to host critical business applications. The deployment team is prioritizing speed to market and has opted to use the default security settings provided by VMware for the XE hosts and vCenter server, with plans to address security hardening in a later phase. Which of the following actions best represents a professional and compliant approach to this scenario? Option A. Immediately implement a documented security hardening guide for XE hosts and vCenter server, aligning with VMware's security best practices for vSphere 6. 7. Before bringing the environment into production. Option B. Deploy the environment with default settings and rely on network-level security controls, such as firewalls, to protect the vSphere infrastructure. Option C. Focus on deploying the necessary virtual machines and applications first, and defer all vSphere security hardening until after the initial application deployment is complete. Option D. Proceed with the deployment using default settings and schedule a security review for the environment within the first 6 months of operation. The correct answer is A. Immediately implement a documented security hardening guide for XE hosts and vCenter server, aligning with VMware's security best practices for vSphere 6. 7. Before bringing the environment into production. Explanation. The assessment process reveals a common challenge in IT environments, ensuring that deployed software and configurations adhere to established security and operational standards. In the context of VMware vSphere 6. 7. This translates to maintaining a secure and compliant infrastructure. The professional challenge lies in balancing the need for rapid deployment and feature utilization with the imperative to maintain a secure posture and avoid introducing vulnerabilities or non-compliance. This requires a proactive and systematic approach to configuration management and security hardening. The correct approach represents best professional practice because it directly addresses the core principles of secure system deployment and ongoing management. By leveraging VMware's built-in security features and adhering to documented best practices, administrators can establish a baseline of security and compliance. This proactive stance minimizes the attack surface, reduces the risk of misconfigurations leading to security breaches, and ensures that the environment is auditable and maintainable. This aligns with the general principles of IT governance and risk management, which are implicitly supported by the foundational knowledge expected in a vSphere 6. 7 exam. An incorrect approach that involves deploying virtual machines without applying security baseline or hardening measures represents a significant regulatory and ethical failure. It introduces unnecessary risk by leaving systems vulnerable to known exploits and unauthorized access. This directly contravenes the principle of due diligence in system administration, which mandates taking reasonable steps to protect data and systems. Furthermore, it can lead to non-compliance with internal security policies and potentially external regulations if sensitive data is involved, creating legal and reputational liabilities. Another incorrect approach, such as relying solely on vendor defaults without any security review, is also professionally unacceptable. Vendor defaults are often designed for broad compatibility and ease of initial setup, not necessarily for maximum security. Failing to review and adjust these defaults means that potentially insecure configurations are left in place, creating a similar risk profile to not applying any hardening at all. This demonstrates a lack of critical assessment and a failure to implement a defense-in-depth strategy. A third incorrect approach, which is to ignore security updates and patches for the vSphere environment, is a critical failure. This directly exposes the infrastructure to known vulnerabilities that have been addressed by the vendor. The ethical and professional obligation is to maintain systems in a secure and up-to-date state to protect the integrity and confidentiality of data. Neglecting patches is a dereliction of this duty and significantly increases the likelihood of a security incident. The professional decision-making process for similar situations should involve a risk-based approach. Before deploying any new systems or making significant configuration changes, administrators should 1. Identify potential security risks and compliance requirements. 2. Consult established security baselines and vendor best practices for the specific technology, in this case, vSphere 6. 7. 3. Implement necessary security controls and hardening measures. 4. Regularly review and update configurations and security settings. 5. Stay informed about security advisories and apply patches promptly. This systematic process ensures that security and compliance are integrated into the operational lifecycle rather than being an afterthought. Question 5. Examination of the data shows that several virtual machines are consistently reporting high CPU and memory utilization. Some of these VMs host critical business applications with strict performance service level agreements, SLAs. What is the most appropriate approach to address this situation? Option A. Rely solely on vSphere's Distributed Resource Scheduler, DRS, to automatically rebalance the virtual machines across hosts without any prior analysis of specific VM needs or host capabilities. Option B. Conduct a thorough analysis of performance metrics for the affected VMs and their underlying hosts, correlating utilization with application SLAs, and then implement targeted resource adjustments using resource pools, reservation, and limits, potentially leveraging DRS for dynamic balancing. Option C. Manually reassign the most critical VMs to hosts with the highest available resources based on a subjective assessment of their importance without detailed performance data. Option D. Immediately increase the allocated CPU and memory resources for all VMs exhibiting high utilization to ensure they have sufficient capacity. The correct answer is B. Conduct a thorough analysis of performance metrics for the affected VMs and their underlying hosts, correlating utilization with application SLAs, and then implement targeted resource adjustments using resource pools, reservations, and limits, potentially leveraging DRS for dynamic balancing. Explanation. Scenario analysis. The scenario presents a common challenge in virtualized environments, balancing performance optimization with resource allocation to meet diverse application demands. The professional challenge lies in making informed decisions about resource provisioning without negatively impacting critical services or incurring unnecessary costs. This requires a deep understanding of vSphere resource management principles and the ability to interpret performance metrics accurately. Correct approach analysis. The correct approach involves a systematic, data-driven evaluation of resource utilization and application requirements. This aligns with best practices for virtual infrastructure management, emphasizing proactive monitoring and informed adjustments. By analyzing performance metrics such as CPU ready time, memory ballooning, and disk latency, and correlating these with application SLAs, administrators can identify genuine resource contention. Implementing resource pools with appropriate reservations and limits, and considering vSphere DRS for automated load balancing, are standard, effective methods for optimizing performance and ensuring availability. This approach is ethically sound as it prioritizes service continuity and efficient resource use, avoiding over-provisioning which can be wasteful, or under-provisioning which can lead to performance degradation and potential SLA breaches. Incorrect approaches analysis. One incorrect approach involves immediately increasing resources for all VMs exhibiting high utilization without further investigation. This is professionally unsound because high utilization does not always equate to a resource bottleneck. It could be due to inefficient application code, suboptimal VM configuration, or transient spikes. Blindly increasing resources leads to over-provisioning, which is wasteful of hardware and licensing costs, and can mask underlying issues. This approach fails to adhere to principles of efficient resource management and can be seen as a lack of due diligence. Another incorrect approach is to solely rely on vSphere's automated features like DRS without understanding the underlying metrics or application needs. While DRS is a powerful tool, its effectiveness is dependent on proper configuration and understanding of the environment. Without a baseline analysis, DRS might make suboptimal decisions, potentially migrating VMs to less suitable hosts or failing to address the root cause of performance issues. This demonstrates a lack of proactive management and an over-reliance on automation without critical oversight, which can lead to unexpected performance degradation. A third incorrect approach is to prioritize VMs based on perceived importance without objective data. This subjective prioritization can lead to critical applications being starved of resources if their needs are not accurately assessed and communicated. It bypasses the systematic process of performance analysis and SLA adherence, potentially leading to service disruptions and reputational damage. This approach lacks the rigor required for professional infrastructure management. Professional reasoning. Professionals should adopt a structured decision-making process that begins with defining clear objectives and understanding application requirements and SLAs. This is followed by comprehensive data collection and analysis of performance metrics. Based on this analysis, appropriate resource management strategies, including the use of resource pools, reservations, limits, and automation tools like DRS should be implemented. Regular review and adjustment of these configurations are crucial to maintain optimal performance and cost efficiency. This methodical approach ensures that decisions are data-driven, justifiable, and aligned with business objectives and best practices. Question 6. Performance analysis shows that several virtual machines are experiencing significant slowdowns and unresponsiveness. The virtual machines are hosted on multiple XE hosts within a vSphere 6/7 cluster, utilizing shared storage. What is the most appropriate initial step to diagnose the root cause of this performance degradation? Option A. Focus on optimizing the guest operating system settings within each affected virtual machine. Option B. Examine the resource utilization metrics, CPU, memory, network, disk I/O, of the XE host hosting the affected virtual machines. Option C. Implement aggressive memory ballooning and storage I/O control adjustments across the cluster. Option D. Immediately begin troubleshooting network connectivity and latency issues between the affected virtual machines and their clients. Correct answer is B. Examine the resource utilization metrics, CPU, memory, network, disk I/O, of the XE host hosting the affected virtual machines. Explanation. Scenario analysis. This scenario presents a common challenge in virtualized environments where performance degradation is observed, but the root cause is not immediately obvious. A professional must move beyond superficial observations to systematically identify the underlying issue. The challenge lies in distinguishing between symptoms and root causes, and in selecting diagnostic steps that are efficient, effective, and adhere to best practices for VMware vSphere 6/7 environments. Misinterpreting performance metrics or jumping to conclusions can lead to wasted resources, prolonged downtime, and potential data integrity issues, all of which have significant operational and potentially compliance implications. Correct approach analysis. The correct approach involves a methodical investigation starting with the most likely and impactful areas. In a vSphere 6/7 environment, performance issues often stem from resource contention at the host, storage, or network layers. Examining host resource utilization, CPU, memory, network, disk I/O, provides a foundational understanding of whether the physical infrastructure is overloaded. If host resources appear healthy, the next logical step is to investigate storage performance, as this is a frequent bottleneck in virtualized environments. Analyzing storage latency, IOPS, and throughput for the data stores hosting the affected virtual machines is critical. This systematic approach ensures that the investigation progresses from general to specific, minimizing the chance of overlooking a critical factor and maximizing the efficiency of troubleshooting. This aligns with best practices for IT service management and operational excellence, which emphasize structured problem solving. Incorrect approach is analysis, focusing solely on the virtual machine's operating system without first examining the underlying vSphere infrastructure is a common pitfall. While OS-level issues can cause performance problems, they are often exacerbated or even caused by inadequate resources provided by the hypervisor or the physical hardware. This approach fails to consider the shared nature of virtualized resources and can lead to misdiagnosis and ineffective remediation. It also risks violating operational guidelines that mandate a layered approach to troubleshooting. Immediately assuming a network issue without a thorough review of host and storage performance is also problematic. While network congestion can impact VM performance, it's less frequently the primary cause of widespread degradation compared to storage or host resource exhaustion. This approach lacks a systematic basis and can lead to chasing phantom network problems, diverting attention from more probable causes. It represents a failure to follow a logical diagnostic methodology. Implementing broad, unverified changes to vSphere configuration settings, such as memory ballooning or storage I/O control parameters, without a clear understanding of the root cause, is a highly risky and unprofessional approach. Such actions can have unintended consequences, potentially worsening performance or destabilizing the environment. This violates principles of change management and risk mitigation, and could be seen as a failure to exercise due diligence in managing critical IT infrastructure. Professional reasoning. Professionals should adopt a structured, layered troubleshooting methodology. This involves starting with broad checks of the most common and impactful areas, host resources, storage, network, and progressively narrowing down the scope based on observed data. Before making any changes, Thorough analysis and understanding of the root cause are paramount. Documenting all diagnostic steps and findings is essential for knowledge sharing and future problem resolution. Adherence to established ITIL or similar frameworks for incident management and problem management provides a robust decision-making process. Question 7. The risk matrix shows a potential performance degradation impacting a critical application hosted on VMware vSphere 6. 7. The application's performance metrics indicate occasional high CPU utilization on the virtual machine. The administrator is considering several immediate actions to address this. Which of the following approaches is the most professionally sound and aligned with best practices for diagnosing and resolving performance issues in a vSphere environment? Option A. Investigate the specific workload characteristics and resource demands of the application to identify the actual bottleneck before making changes. Option B. Increase the amount of RAM allocated to the virtual machine. Option C. Immediately increase the number of virtual CPUs, vCPU, assigned to the virtual machine. Option D. Migrate the virtual machine to a different XC host with potentially more available resources. The correct answer is C. Immediately increase the number of virtual CPUs, vCPU, assigned to the virtual machine. Explanation. This scenario presents a common implementation challenge in virtualized environments, balancing performance optimization with resource availability and potential licensing implications. The professional challenge lies in making a decision that impacts system performance, cost, and potentially compliance without a clear, universally right answer, requiring careful consideration of multiple factors. The correct approach represents best professional practice because it prioritizes a thorough understanding of the underlying cause of the performance issue before implementing a solution. This aligns with the principle of informed decision-making, which is crucial in IT operations. By investigating the specific workload and its resource demands, the administrator can determine if the current configuration is truly suboptimal or if the issue stems from external factors. This methodical approach minimizes the risk of introducing new problems, unnecessary costs, or violating licensing agreements, which could have regulatory or financial repercussions. An incorrect approach that immediately increases vCPU allocation without investigation is professionally unacceptable. This could lead to over-licensing if the software being run is licensed per vCPU, violating licensing agreements and potentially incurring significant financial penalties. It also ignores the possibility that the performance issue is not directly related to vCPU contention, meaning the change would be ineffective and wasteful. Furthermore, increasing vCPU allocation can sometimes negatively impact performance due to increased scheduling overhead, a phenomenon known as vCPU oversubscription. Another incorrect approach, focusing solely on increasing RAM, fails to address the root cause if the bottleneck is indeed CPU. This is a reactive rather than proactive solution, potentially masking the real problem and leading to inefficient resource utilization. It also carries the risk of unnecessary hardware investment if the issue is not memory-bound. Finally, an approach that involves migrating the workload to a different host without understanding the performance characteristics of that host or the workload itself is also professionally unsound. This is a form of hope and pray troubleshooting, which can lead to unpredictable results and may simply shift the problem elsewhere without resolving it. It lacks the systematic analysis required for effective problem solving. The professional reasoning process for similar situations should involve a structured troubleshooting methodology. This typically includes defining the problem, gathering information, identifying potential causes, testing hypotheses, implementing solutions, and verifying the results. In this context, it means moving beyond assumptions and using available monitoring tools to diagnose the actual performance bottleneck before making any changes. This data-driven approach ensures that solutions are targeted, effective, and compliant with any relevant operational guidelines or licensing terms. Question 8. Upon reviewing the security advisories for VMware vSphere 6, 7, a critical vulnerability has been identified that could potentially allow unauthorized access to sensitive data within virtual machines. The vSphere environment is currently running without any active security incidents, and the business operations are not immediately impacted. What is the most appropriate initial step to address this vulnerability? Option A. Revert the vSphere environment to a previous stable snapshot to eliminate the possibility of the vulnerability being exploited. Option B. Document the vulnerability and decide to monitor the situation, as there are no active security incidents and no immediate business impact. Option C. Immediately apply the latest security patch released by VMware to address the vulnerability. Option D. Conduct a thorough risk assessment to understand the specific threat, potential impact, and available mitigation options before implementing any changes. The correct answer is D. Conduct a thorough risk assessment to understand the specific threat, potential impact, and available mitigation options before implementing any changes. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system availability with the long-term security posture of the vSphere environment. A rushed decision without proper risk assessment can lead to vulnerabilities that are difficult and costly to remediate later. The core of the challenge lies in understanding the potential impact of a security vulnerability on business operations and data integrity, and then selecting the most appropriate mitigation strategy within the constraints of the VMware vSphere 6.7 environment. The correct approach represents best professional practice because it prioritizes a structured and documented process for evaluating and addressing security risks. By performing a thorough risk assessment, the administrator can identify the specific threats, vulnerabilities, and potential impacts associated with the identified security issue. This allows for an informed decision on the most effective and least disruptive remediation strategy. This aligns with general IT best practices for security management, which emphasize proactive identification and mitigation of risks. While the 2V0-01-19 exam focuses on technical foundations, the underlying principle of responsible system management, which includes risk assessment, is implicitly expected. An incorrect approach that involves immediately applying a patch without understanding its full implications is professionally unacceptable. This bypasses the critical step of risk assessment and could introduce new, unforeseen issues or incompatibilities, potentially leading to system instability or further security breaches. This demonstrates a failure in due diligence and a disregard for the potential consequences of hasty actions. Another incorrect approach, which is to ignore the vulnerability due to perceived low immediate impact, is also professionally unsound. This represents a failure to proactively manage security risks. While the immediate impact might seem negligible, leaving known vulnerabilities unaddressed creates a window of opportunity for attackers to exploit them, potentially leading to significant data loss, service disruption, or reputational damage. This demonstrates a lack of foresight and a failure to uphold the responsibility of protecting the IT infrastructure. The professional reasoning process for similar situations should involve a systematic approach to security incident and vulnerability management. This includes 1. Identification of the vulnerability or incident. 2. Assessment of the risk, considering the likelihood of exploitation and the potential impact. 3. Evaluation of mitigation options, including patching, configuration changes, or workarounds. 4. Implementation of the chosen mitigation strategy with thorough testing. 5. Verification of the effectiveness of the mitigation. 6. Documentation of the entire process. This structured approach ensures that decisions are data-driven, justifiable, and aligned with the organization's security objectives. Question 9. The efficiency study reveals that the current vSphere networking configuration is a significant bottleneck, impacting virtual machine performance and overall data center responsiveness. To address this, a vSphere distributed switch (VDS) upgrade is being considered to leverage enhanced features and improve network throughput. The IT team needs to determine the most professional and risk-averse approach to implement this critical upgrade in a production environment. Option A. Upgrade the vSphere distributed switch on a small, non-critical subset of hosts, first to gauge the impact before proceeding with a full rollout. Option B. Conduct a comprehensive upgrade of the vSphere distributed switch across all hosts during a scheduled, low-impact maintenance window, following extensive pre-upgrade testing in a lab environment and establishing a detailed rollback plan. Option C. Implement the vSphere distributed switch upgrade on a few key hosts during peak operational hours, assuming the benefits will outweigh any temporary disruptions. Option D. Perform the upgrade immediately during business hours to resolve the performance issues as quickly as possible. The correct answer is D. Perform the upgrade immediately during business hours to resolve the performance issues as quickly as possible. Explanation. Scenario analysis. This scenario presents a common implementation challenge where a critical infrastructure component, vSphere networking, needs to be upgraded to address performance bottlenecks identified by an efficiency study. The challenge lies in balancing the need for improved performance and stability with the inherent risks of modifying a production environment. A misstep during the upgrade could lead to significant downtime, data loss, or security vulnerabilities, impacting business operations and potentially violating service-level agreements, SLAs. The professional challenge is to select an upgrade strategy that minimizes risk while achieving the desired technical outcome. Correct approach analysis. Implementing the vSphere distributed switch (VDS) upgrade during a scheduled maintenance window, with thorough pre-upgrade testing in a lab environment and a rollback plan, represents best professional practice. This approach adheres to fundamental IT service management principles, such as change management and risk mitigation. By testing in a non-production environment, potential issues can be identified and resolved before impacting live systems. Scheduling the upgrade during a maintenance window minimizes the impact on end users and business operations. A well-defined rollback plan ensures that if unforeseen problems arise, the environment can be quickly restored to its previous stable state, thereby maintaining service availability and preventing data loss. This proactive and controlled approach aligns with the implicit expectation of maintaining a stable and reliable IT infrastructure, a core tenet of professional IT operations. Incorrect approach is analysis. Performing the upgrade immediately without any prior testing in a lab environment is a significant regulatory and ethical failure. It demonstrates a disregard for risk management and could lead to widespread service disruption, potentially violating contractual obligations with stakeholders or customers regarding uptime and performance. This approach is unprofessional as it prioritizes speed over safety and reliability. Upgrading only a subset of hosts without a clear understanding of the interdependencies and potential network inconsistencies across the vSphere environment is also professionally unacceptable. This can lead to a fragmented and unstable network, causing unpredictable behavior and performance issues. It fails to address the root cause comprehensively and introduces new complexities, potentially violating the principle of maintaining a consistent and well-managed infrastructure. Attempting the upgrade during peak business hours without a maintenance window or rollback plan is a severe ethical and professional lapse. This action directly jeopardizes business continuity and demonstrates a lack of consideration for the impact on users and operations. It is a reckless approach that could result in significant financial losses and reputational damage, failing to uphold the professional responsibility to safeguard operational integrity. Professional reasoning. Professionals should approach such implementation challenges by first thoroughly understanding the problem and its impact. This involves reviewing efficiency studies, performance metrics, and potential risks. The next step is to explore various technical solutions, evaluating each based on its effectiveness, feasibility, and risk profile. A structured change management process, including detailed planning, testing in a controlled environment, and the development of comprehensive rollback procedures, is paramount. Communication with all relevant stakeholders regarding the planned changes, potential impacts, and timelines is also a critical component of professional decision-making. The ultimate goal is to implement changes that enhance the environment while minimizing disruption and risk. Question 10. Cost-benefit analysis shows that a critical business application experiencing performance bottlenecks requires a storage solution upgrade. The application's workload is characterized by a mix of high-frequency, low-latency read/write operations for active data and less frequent access to historical data. The current storage infrastructure is nearing its capacity and performance limits. Which of the following storage implementation strategies would best address the application's needs while optimizing resource utilization and cost? Option A. Migrate the application to a new cloud-based storage service without a thorough assessment of its specific performance and cost implications for this workload. Option B. Immediately upgrade all existing storage to the highest performance SSD array available to ensure maximum throughput for all application data. Option C. Implement a tiered storage solution, utilizing high-performance SSDs for the active data set and a less expensive, higher-capacity storage tier for historical data, integrated with vSphere. Option D. Consolidate the application onto a single, general-purpose storage array that offers a balance of capacity and performance, assuming it can handle the current load. The correct answer is C. Implement a tiered storage solution, utilizing high-performance SSDs for the active data set and a less expensive, higher-capacity storage tier for historical data, integrated with vSphere. Explanation: this scenario presents a common implementation challenge in virtualized environments, balancing performance needs with resource constraints and licensing implications. The professional challenge lies in selecting a storage solution that meets the immediate demands of a critical application, while adhering to the principles of efficient resource utilization and avoiding unnecessary expenditure, all within the context of VMware's architectural best practices. Careful judgment is required to avoid over-provisioning or under-provisioning resources, which can lead to performance degradation, increased costs, or compliance issues. The correct approach represents best professional practice because it prioritizes a solution that is scalable, cost-effective, and leverages existing infrastructure where possible. By choosing a tiered storage strategy that aligns with the application's I/O requirements and data criticality, administrators can optimize performance for the most demanding data while using less expensive storage for less critical data. This approach demonstrates a thorough understanding of storage technologies and their impact on virtual machine performance and operational costs. It aligns with the principle of providing the necessary resources without waste, a key tenet of efficient IT management. An incorrect approach that involves immediately deploying expensive, high-performance storage for all aspects of the application, without a detailed analysis of I/O patterns, represents a failure in cost management and resource optimization. This could lead to significant overspending on hardware and licensing, which is professionally unacceptable as it deviates from the principle of fiscal responsibility. Another incorrect approach, such as relying solely on basic storage without considering the application's performance needs, would likely result in poor application responsiveness and user dissatisfaction, failing to meet the core requirement of supporting the critical application effectively. A third incorrect approach, such as implementing a complex unproven storage solution without adequate testing or vendor support, introduces unnecessary risk and potential for operational disruption, which is professionally unsound. Professionals should employ a decision-making framework that begins with a clear understanding of application requirements, including performance metrics, IOPS, latency, data criticality, and growth projections. This should be followed by an assessment of available storage technologies and their respective cost-performance profiles. A phased implementation or pilot testing of potential solutions is advisable before full deployment. Finally, ongoing monitoring and performance tuning are crucial to ensure the chosen solution continues to meet evolving needs and remains cost-effective. Question 11. Research into the most effective strategy for restoring network connectivity for virtual machines following an unexpected XC host failure in a vSphere 6/7 environment, considering the need for minimal downtime and automated recovery. Option A. Disable network adapter redundancy on the virtual machines to simplify troubleshooting during the recovery process. Option B. Manually reconfigure the network adapter settings on each affected virtual machine on the surviving hosts. Option C. Leverage vSphere High Availability (HA) to automatically restart virtual machines on healthy hosts and ensure their network configurations are preserved. Option D. Initiate a full backup and restore of the affected virtual machines to a different vSphere cluster. The correct answer is B. Manually reconfigure the network adapter settings on each affected virtual machine on the surviving hosts. Explanation: this scenario presents a common implementation challenge in virtualized environments, ensuring consistent and reliable network connectivity for virtual machines after a host failure. The professional challenge lies in selecting the most robust and efficient method for restoring network services without compromising data integrity or introducing new vulnerabilities. The chosen approach must align with best practices for high availability and disaster recovery, as outlined in general IT operational guidelines, and implicitly supported by the principles of maintaining service continuity, which are paramount in any regulated IT environment. The correct approach represents best professional practice because it prioritizes a proactive and automated recovery process. By leveraging vSphere's built-in high availability features, such as vSphere HA, the system is designed to automatically detect host failures and restart affected virtual machines on healthy hosts. This minimizes downtime and ensures that critical services remain accessible, thereby adhering to the implicit requirement of maintaining operational resilience and service availability. This method is efficient, reduces manual intervention, and is a standard component of a well-designed virtual infrastructure. An incorrect approach that involves manually reconfiguring network settings on each affected virtual machine after a failure is professionally unacceptable. This method is prone to human error, leading to misconfigurations, extended downtime, and potential security vulnerabilities. It directly contradicts the principles of efficient resource management and rapid service restoration expected in a professional IT setting. Furthermore, relying on manual intervention in a critical failure scenario can be seen as a failure to implement adequate business continuity measures, potentially violating service-level agreements or internal operational policies that mandate swift recovery. Another incorrect approach, such as disabling network adapter redundancy on the virtual machines to simplify troubleshooting, is also professionally unsound. This action directly compromises the resilience of the virtual machine's network connectivity, making them more susceptible to single points of failure. It demonstrates a lack of understanding of network design principles for high availability and introduces unnecessary risk. This approach fails to address the root cause of the problem and instead creates a more fragile environment. The professional decision-making process for similar situations should involve a thorough assessment of the potential impact of a failure, the available recovery mechanisms, and the associated risks. Professionals should prioritize solutions that offer automated, reliable, and efficient recovery. This involves understanding the capabilities of the virtualization platform, adhering to established IT best practices for disaster recovery and business continuity, and conducting regular testing of recovery procedures. The decision should always favor methods that minimize downtime, reduce the likelihood of human error, and maintain the integrity and security of the virtualized environment. Question 12. The monitoring system demonstrates a virtual machine experiencing consistently high CPU utilization, impacting its responsiveness. As the vSphere administrator, what is the most appropriate initial course of action to address this performance degradation? Option A. Analyze detailed performance metrics and logs for the virtual machine and its host to identify the root cause before taking action. Option B. Disable monitoring for the affected virtual machine to prevent further alerts while investigating. Option C. Increase the virtual machine's allocated CPU resources to alleviate the high utilization. Option D. Immediately restart the virtual machine to clear any potential transient issues. Correct answer is D. Immediately restart the virtual machine to clear any potential transient issues. Explanation. This scenario presents a common implementation challenge in virtualized environments, balancing performance monitoring with resource allocation to ensure optimal application availability and user experience. The challenge lies in accurately interpreting monitoring data and taking appropriate, non-disruptive actions without impacting production workloads. The specific regulatory framework for the 2V0-01, 19 VMware vSphere 6, 7 Foundations Exam 2019, while not explicitly detailing specific external regulations, implies adherence to best practices for IT infrastructure management, which inherently includes operational integrity and data security. The correct approach represents best professional practice because it prioritizes a systematic, data-driven, and non-disruptive method to address performance degradation. By first analyzing the root cause of the high CPU utilization through detailed performance metrics and logs, the administrator can identify whether the issue is application-specific, host-related, or a broader cluster problem. This methodical investigation prevents hasty decisions that could exacerbate the situation. The subsequent step of isolating the affected virtual machine for further troubleshooting, potentially by migrating it to a less utilized host if necessary, is a standard operational procedure that minimizes impact on other services. This aligns with the implicit professional responsibility to maintain service availability and data integrity within the vSphere environment. An incorrect approach that immediately restarts the virtual machine without investigation is professionally unacceptable. This action bypasses the critical step of root cause analysis, potentially masking underlying issues that could recur or lead to more severe problems. It also risks data loss or corruption if the application is not in a consistent state. Ethically, this demonstrates a lack of due diligence and a failure to uphold the principle of responsible system administration. Another incorrect approach, such as immediately increasing the CPU resources allocated to the virtual machine, is also problematic. While seemingly a direct solution, it fails to address the underlying cause of the high utilization. This can lead to inefficient resource allocation, potentially starving other virtual machines on the same host, and can mask application-level inefficiencies that should be addressed. This approach lacks the analytical rigor expected of a professional and could violate operational best practices by over-provisioning resources without justification. Finally, an approach that involves disabling monitoring for the affected virtual machine is a severe ethical and professional failure. This action directly undermines the purpose of a monitoring system and creates a blind spot in the infrastructure's observability. It is akin to ignoring a warning light on a vehicle's dashboard, increasing the risk of undetected failures and significant service disruptions. This violates the fundamental professional obligation to maintain a secure and observable IT environment. The professional decision-making process for similar situations should involve a structured approach. 1. Acknowledge and validate the alert from the monitoring system. 2. Gather detailed performance metrics and logs related to the alert. 3. Analyze the data to identify the root cause of the issue. 4. Formulate a plan of action based on the root cause, prioritizing non-disruptive solutions. 5. Implement the plan, carefully monitoring the impact of each step. 6. Document the issue, the resolution, and any lessons learned. Question 13. Operational review demonstrates that a critical business application hosted on a VMware vSphere 6.7 virtual machine is experiencing intermittent and significant performance degradation, impacting user productivity. The issue appears to be localized to this specific virtual machine, though other VMs on the same XC host are not reporting similar problems. The IT operations team needs to quickly diagnose and resolve the performance bottleneck. Which of the following actions represents the most professional and effective approach to resolving this implementation challenge? Option A. Utilize vSphere performance monitoring tools to analyze the virtual machines and its host's CPU ready time, disk latency, and network throughput metrics to identify resource contention. Option B. Proactively increase the virtual machine's allocated CPU and memory resources in vCenter server, anticipating a resource starvation issue. Option C. Immediately migrate the virtual machine to a different XC host within the cluster, assuming the current host is overloaded. Option D. Advise the application support team to perform in-depth application profiling and optimization, as the performance issue is likely application-specific. The correct answer is C. Immediately migrate the virtual machine to a different XC host within the cluster, assuming the current host is overloaded. Explanation. Scenario analysis. This scenario presents a common implementation challenge in virtualized environments where resource contention can impact application performance and user experience. The challenge lies in accurately identifying the root cause of performance degradation when multiple factors could be at play, such as network latency, storage I/O, or CPU oversubscription. A hasty or incorrect diagnosis can lead to wasted resources, prolonged downtime, and potential financial losses. Professional judgment is required to systematically investigate, isolate the problem, and implement the most effective solution. Correct approach analysis. The correct approach involves a methodical investigation using vSphere's built-in performance monitoring tools. By examining vCenter server performance charts for the affected virtual machine and its host, administrators can pinpoint resource bottlenecks. Specifically, analyzing CPU ready time, disk latency, and network throughput provides concrete data to identify whether the issue stems from CPU contention, storage I/O limitations, or network saturation. This data-driven approach ensures that remediation efforts are targeted and effective, aligning with best practices for maintaining a stable and performant virtual infrastructure. This aligns with the general principles of IT service management and operational excellence expected in a professional IT environment, ensuring that resources are utilized efficiently and service-level agreements are met. Incorrect approach is analysis. One incorrect approach involves immediately migrating the virtual machine to a different host without proper investigation. This is professionally unacceptable because it fails to address the underlying cause of the performance issue. The problem might be systemic to the storage or network infrastructure, and simply moving the VM would not resolve it, potentially impacting other workloads on the new host. It also bypasses the diagnostic steps necessary for proper root cause analysis, which is a fundamental aspect of IT operations. Another incorrect approach is to arbitrarily increase the allocated resources, CPU or RAM, to the virtual machine. This is a reactive measure that can lead to resource over-provisioning, increasing costs, and potentially starving other virtual machines on the same host. Without understanding the actual resource utilization patterns, this action is speculative and does not represent a professional, data-driven troubleshooting methodology. It also fails to identify if the issue is external to the VM's resource allocation, such as network or storage. A third incorrect approach is to assume the issue is with the application itself and recommend application-level tuning without first verifying the virtual infrastructure's health. While application issues can cause performance problems, it is crucial to rule out infrastructure bottlenecks first, especially when multiple VMs on the same host might be experiencing similar symptoms. This approach prematurely dismisses potential infrastructure causes and can lead to unnecessary application-level troubleshooting efforts. Professional reasoning. Professionals should adopt a systematic, data-driven approach to troubleshooting. This involves 1. Defining the problem clearly. What is the observed performance degradation? 2. Gathering data. Utilize vSphere performance monitoring tools to collect metrics related to CPU, memory, disk, and network. 3. Analyzing data. Correlate performance metrics with the observed problem to identify potential bottlenecks. 4. Formulating hypotheses. Based on the data, propose likely causes for the performance issue. 5. Testing hypotheses. Implement targeted changes or further investigations to confirm or refute hypotheses. 6. Implementing solutions. Apply the most effective solution based on confirmed findings. 7. Verifying the solution. Monitor performance to ensure the issue is resolved and no new problems have been introduced. This structured process ensures that decisions are based on evidence, leading to efficient problem resolution and maintaining the integrity of the virtual environment. Question 14. Which approach would be most appropriate when a vendor offering a new VMware vSphere 6.7 feature also offers a significant personal incentive to the IT professional evaluating the feature for potential organizational adoption? Option A. Objectively evaluate the new feature based solely on its technical merits, organizational benefits, and alignment with existing infrastructure, documenting all findings and recommendations without regard to the personal incentive. Option B. Inform the vendor that the personal incentive is inappropriate and decline it, then proceed with a biased evaluation influenced by the vendor's offer. Option C. Immediately reject the new feature and the vendor's offer due to the perceived conflict of interest without conducting any technical evaluation. Option D. Accept the vendor's personal incentive and proceed with a favorable evaluation of the feature, highlighting its strengths while downplaying any potential drawbacks. The correct answer is A. Objectively evaluate the new feature based solely on its technical merits, organizational benefits, and alignment with existing infrastructure, documenting all findings and recommendations without regard to the personal incentive. Explanation. This scenario presents a professional challenge due to the inherent conflict between a vendor's desire to promote their product and the IT professional's responsibility to provide objective, unbiased recommendations based on technical merit and organizational needs. The pressure to accept a beneficial offer from a vendor, even if it doesn't align with the best technical solution for the organization, requires careful ethical consideration and adherence to professional conduct guidelines. The correct approach represents best professional practice because it prioritizes the organization's interests and maintains professional integrity. By clearly documenting the evaluation process, focusing on objective criteria, and transparently communicating findings, the IT professional upholds their duty to act in the best interest of their employer. This aligns with general IT professional ethics that emphasize honesty, objectivity, and competence, ensuring that technology decisions are driven by business requirements and technical suitability, not personal gain or vendor influence. An incorrect approach that involves accepting the vendor's offer without thorough independent evaluation would represent a significant ethical failure. This could be construed as a conflict of interest, where personal benefit, e.g., future opportunities, perceived vendor favor, influences professional judgment, potentially leading to the selection of a suboptimal solution for the organization. This violates the principle of acting with integrity and in the best interest of the employer. Another incorrect approach, accepting the offer and then attempting to justify it post hoc with biased data is also professionally unacceptable. This demonstrates a lack of transparency and honesty, undermining trust within the organization, and potentially leading to the implementation of a solution that does not meet technical or business requirements. It is a form of misrepresentation and a failure to uphold professional accountability. Finally, an approach that involves ignoring the vendor's offer and proceeding with a potentially less efficient or more costly solution without proper justification would also be problematic. While it avoids direct vendor influence, it fails to explore all viable options and could be seen as a missed opportunity for potentially beneficial collaboration or innovation, provided it is handled ethically and objectively. Professional decision-making in such situations requires a structured process, clearly define requirements, conduct a thorough and objective evaluation of all viable solutions, including those proposed by vendors, document the decision-making process, and communicate findings transparently. This framework ensures that decisions are defensible, ethical, and aligned with organizational goals. Question 15. The review process indicates that a critical virtual machine is experiencing intermittent performance degradation, and a senior engineer has requested an immediate, undocumented change to a specific vSphere 6.7 host's advanced configuration setting to temporarily resolve the issue. This setting is not typically modified outside of planned maintenance windows with extensive impact analysis. Option A. Implement the requested advanced configuration change immediately without any documentation or approval, as the urgency of the performance issue takes precedence. Option B. Refuse to make any configuration changes to the vSphere host, citing policy, and instruct the senior engineer to troubleshoot the issue through other means. Option C. Implement the requested advanced configuration change and document it only after the performance issue is confirmed as resolved. Option D. Document the requested change, assess its potential impact, and submit it through the standard change control process for approval before implementation, even if it causes a delay in the immediate resolution. The correct answer is D. Document the requested change, assess its potential impact, and submit it through the standard change control process for approval before implementation, even if it causes a delay in the immediate resolution. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data integrity and adhere to established operational procedures within a VMware vSphere 6.7 environment. The core conflict arises from a request that, while seemingly beneficial for immediate troubleshooting, bypasses standard change control and validation processes. The pressure to resolve an issue quickly can tempt individuals to take shortcuts, but this can lead to unintended consequences, security vulnerabilities, and a breakdown of trust in the IT infrastructure. The professional must balance the urgency of the immediate problem with the long-term implications of deviating from best practices and documented procedures. Correct approach analysis. The correct approach involves documenting the proposed change, assessing its potential impact, obtaining necessary approvals through the established change control process, and then implementing the change with proper validation. This aligns with the principles of responsible IT management, emphasizing transparency, accountability, and risk mitigation. In the context of VMware vSphere 6.7, this means following the documented procedures for configuration changes, which are designed to prevent accidental misconfigurations, ensure rollback capabilities, and maintain a secure and stable environment. Adhering to these processes is not just about compliance. It's about ensuring the reliability and security of the virtual infrastructure, which is critical for business operations. Incorrect approaches analysis. One incorrect approach involves immediately implementing the requested change without any formal documentation or approval. This bypasses the change control process, which is a fundamental control mechanism for managing IT infrastructure. The regulatory and ethical failure here is a disregard for established procedures designed to prevent errors, ensure accountability, and maintain system stability. This can lead to unauthorized modifications, security breaches, and an inability to trace the root cause of future issues. Another incorrect approach is to refuse the request outright without offering an alternative or explaining the process. While caution is warranted, a complete refusal without attempting to find a compliant solution can hinder problem resolution and damage stakeholder relationships. The ethical failure lies in a lack of collaboration and a failure to uphold the duty to support business operations within acceptable risk parameters. A third incorrect approach is to implement the change but fail to document it afterward. This creates an unknown in the system, making future troubleshooting and auditing extremely difficult. The regulatory and ethical failure is a breach of the principle of maintaining accurate and complete system records, which is essential for compliance, security, and operational continuity. It undermines the integrity of the IT environment and can lead to significant compliance issues if an audit is performed. Professional reasoning. Professionals in this field must develop a decision-making framework that prioritizes adherence to established procedures while remaining responsive to urgent needs. This involves 1. Understanding the established change management and operational procedures. 2. Assessing the urgency and impact of the request. 3. Communicating the process and potential risks of deviation to stakeholders. 4. Seeking appropriate approvals and documentation. 5. Implementing changes methodically and validating outcomes. 6. Ensuring all actions are logged and documented. This systematic approach ensures that immediate issues are addressed without compromising the long-term integrity, security, and compliance of the virtual environment. Question 16. The analysis reveals that a critical virtual machine's network configuration within a VMware vSphere 6.7 environment appears to be misaligned with the intended security policies, potentially exposing sensitive data. The system administrator has the technical capability to directly edit the VM's configuration files to correct this discrepancy, but has not received explicit authorization for such an immediate intervention. The administrator is aware that the standard change management process for such modifications can take several business days to complete. What is the most professionally responsible course of action? Option A. Proceed with the configuration change and then submit a retrospective change request to document the action taken, assuming the risk of immediate exposure is high. Option B. Ignore the observed misconfiguration for now, as the standard change management process is in place to address such issues over time, and direct intervention could introduce unforeseen problems. Option C. Directly edit the virtual machine's configuration files to correct the network settings, as the potential for data exposure outweighs the need for formal authorization in this instance. Option D. Document the observed misconfiguration. Immediately escalate the issue to the security and operations management teams, and await formal approval and guidance before making any changes. The correct answer is D. Document the observed misconfiguration. Immediately escalate the issue to the security and operations management teams, and await formal approval and guidance before making any changes. Explanation. This scenario presents a professional challenge rooted in the ethical responsibility to maintain data integrity and system security within a VMware vSphere 6.7 environment, particularly concerning the potential for unauthorized access or modification of sensitive virtual machine configurations. The core of the dilemma lies in balancing the immediate need for a quick resolution with the long-term implications of bypassing established security protocols. The correct approach, which involves documenting the issue, seeking proper authorization, and implementing the change through approved channels, represents best professional practice because it upholds the principles of accountability, transparency, and adherence to organizational policies. In the context of VMware vSphere 6.7, this aligns with the foundational security and operational best practices expected of IT professionals. It ensures that all changes are auditable, traceable, and have undergone appropriate review, thereby minimizing the risk of introducing unintended vulnerabilities or operational disruptions. This methodical approach is crucial for maintaining the trust placed in IT professionals to manage critical infrastructure responsibly. An incorrect approach that involves directly modifying the VM's configuration files without authorization or documentation is professionally unacceptable. This action constitutes a significant breach of security protocols and ethical conduct. It bypasses the established change management process, which is designed to prevent unauthorized access and ensure that all modifications are vetted for potential impact. Such an action could lead to system instability, data corruption, or security breaches, all of which have severe operational and reputational consequences. Furthermore, it undermines the integrity of audit trails, making it impossible to determine the cause of future issues. Another incorrect approach, such as ignoring the issue and hoping it resolves itself, is also professionally unsound. This demonstrates a lack of proactive problem solving and a disregard for potential system vulnerabilities. It creates a hidden risk that could manifest later, potentially with more severe consequences. This passive stance fails to meet the professional obligation to maintain a secure and stable environment. A professional decision-making process for similar situations should involve a structured approach. 1. Identify and clearly define the problem. 2. Assess the potential impact and risks associated with the problem. 3. Consult relevant organizational policies, procedures, and documentation. 4. Determine the appropriate course of action, prioritizing security and integrity. 5. Seek necessary approvals and authorizations before implementing any changes. 6. Document all actions taken, including the problem, the solution, and the authorization. 7. Communicate changes to relevant stakeholders. 8. Verify the successful implementation of the solution and monitor for any adverse effects. Question 17. Market research demonstrates that clients often place significant emphasis on performance metrics when evaluating IT infrastructure solutions. During a routine performance review of a VMware vSphere 6.7 environment, you discover a single, isolated instance where a virtual machine experienced a significant, unexplained performance degradation for a brief period, skewing the overall average performance metric. You are preparing a report for a key stakeholder who is highly focused on these average metrics. What is the most ethically sound and professionally responsible course of action? Option A. Exclude the anomalous data point from the report to ensure the average metric presented is representative of the typical performance. Option B. Present the average performance metric without mentioning the anomaly, assuming the stakeholder will not notice or question it. Option C. Include the anomalous data point in the report and provide a brief, factual note explaining that an isolated performance anomaly was observed and is being investigated. Option D. Fabricate a plausible technical reason for the anomaly to explain the deviation without raising concerns about the stability of the environment. The correct answer is C. Include the anomalous data point in the report and provide a brief, factual note explaining that an isolated performance anomaly was observed and is being investigated. Explanation. This scenario presents a professional challenge rooted in the ethical obligation to maintain data integrity and avoid misrepresentation, particularly when dealing with performance metrics that could influence client perception or future engagements. The core of the dilemma lies in balancing the desire to showcase positive outcomes with the imperative of accurate and transparent reporting. Careful judgment is required to navigate the temptation to selectively present data in a way that might be misleading, even if not overtly fraudulent. The correct approach represents best professional practice because it adheres to the principles of honesty, accuracy, and transparency in reporting. By acknowledging the anomaly and providing context, the professional demonstrates a commitment to factual reporting, which is fundamental to building and maintaining trust with clients and stakeholders. This approach aligns with general ethical guidelines for IT professionals, emphasizing the importance of integrity in all professional dealings. While the 2V0-01 19 exam focuses on technical foundation, the underlying ethical responsibilities of IT professionals are implicitly understood as part of competent practice. An incorrect approach that involves omitting the anomalous data point is ethically unacceptable because it constitutes a form of data manipulation through omission, leading to a misrepresentation of the system's performance. This failure violates the principle of honesty and can erode trust if discovered. Another incorrect approach, which involves fabricating a justification for the anomaly without factual basis, is a direct breach of integrity and honesty, bordering on professional misconduct. It creates a false narrative and undermines the credibility of the reporting. Finally, an approach that involves presenting the data without any explanation or acknowledgement of the anomaly, while not actively falsifying, still falls short of best practice by failing to provide a complete and transparent picture, potentially leading to misinterpretation by the recipient. Professionals should employ a decision-making framework that prioritizes accuracy and transparency. This involves a thorough understanding of the data, identifying any outliers or anomalies, investigating their root cause, and then reporting the findings comprehensively, including any explanations or contextual information. When faced with anomalies, the default should be to investigate and report truthfully, rather than to conceal or manipulate. This builds a reputation for reliability and fosters stronger professional relationships. Question 18. Process analysis reveals that a system administrator has identified a critical security vulnerability in a core VMware vSphere component. The administrator is concerned that reporting this vulnerability immediately through official channels might trigger an urgent, high-priority patch deployment that could disrupt ongoing critical business operations and place an undue burden on their already stretched team, potentially impacting their performance reviews. The administrator is contemplating whether to delay reporting until a more opportune time or attempt to mitigate the risk through less formal means. Option A. Attempt to implement a workaround for the vulnerability independently, without formal notification, to avoid immediate scrutiny. Option B. Downplay the severity of the vulnerability in the initial report to avoid immediate high-priority attention. Option C. Delay reporting the vulnerability until a scheduled maintenance window, hoping to address it with minimal disruption. Option D. Immediately report the vulnerability through the established internal security incident reporting process, irrespective of potential operational disruptions or team workload. The correct answer is D. Immediately report the vulnerability through the established internal security incident reporting process, irrespective of potential operational disruptions or team workload. Explanation. Scenario analysis. This scenario presents an ethical dilemma involving a potential conflict of interest and the responsible use of company resources. A system administrator has discovered a vulnerability that could be exploited, but reporting it might lead to increased workload or scrutiny for their team, potentially impacting their performance metrics. The challenge lies in balancing the immediate operational concerns and team dynamics with the overarching responsibility to maintain system security and integrity, which is a fundamental ethical obligation for IT professionals. The temptation to delay or downplay the issue for personal or team convenience creates a significant ethical hurdle. Correct approach analysis. The correct approach is to immediately and transparently report the discovered vulnerability through the established internal channels, regardless of potential personal or team repercussions. This aligns with the core principles of IT ethics, which prioritize the security and well-being of the organization and its users. Proactive disclosure ensures that the appropriate teams can address the issue before it can be exploited, thereby preventing potential data breaches, service disruptions, and reputational damage. This action demonstrates integrity, accountability, and a commitment to professional responsibility, which are paramount in maintaining trust and upholding industry standards. Incorrect approaches analysis. Delaying the report to gather more information or to manage the situation internally without formal notification is an ethical failure. This approach risks the vulnerability being discovered and exploited by malicious actors before it can be remediated, leading to significant security incidents. It also bypasses established security protocols and demonstrates a lack of transparency, potentially violating organizational policies and professional codes of conduct that mandate timely reporting of security risks. Attempting to fix the vulnerability independently without proper authorization or notification is also an ethical and professional misstep. This can lead to unintended consequences, such as system instability, data corruption, or the introduction of new security flaws. It undermines the established change management and incident response processes, which are designed to ensure that all system modifications are reviewed, tested, and approved to maintain overall system stability and security. This action also constitutes unauthorized access and modification of systems, which can have serious repercussions. Ignoring the vulnerability altogether due to concerns about workload or team performance is a severe ethical breach. This demonstrates a dereliction of duty and a disregard for the organization's security posture. It prioritizes personal or team convenience over the fundamental responsibility to protect the organization's assets and data, which can lead to catastrophic security failures and significant financial and reputational damage. Professional reasoning. Professionals facing such dilemmas should follow a structured decision-making process. First, identify the ethical issue and the stakeholders involved. Second, gather all relevant facts, including the nature of the vulnerability and its potential impact. Third, consult relevant organizational policies, procedures, and professional codes of conduct. Fourth, evaluate the potential consequences of each course of action, considering both immediate and long-term impacts. Fifth, choose the option that best upholds ethical principles and professional responsibilities, prioritizing security, integrity, and transparency. Finally, Document the decision-making process and the actions taken. Question 19. During the evaluation of a critical production vSphere environment experiencing intermittent performance issues, a system administrator identifies a potential workaround involving a temporary modification to a specific virtual machine's network adapter settings. This modification is not part of the standard operating procedures for troubleshooting such issues, but it is believed to be a quick fix to restore immediate functionality for affected users. The administrator is under significant pressure to resolve the problem swiftly. What is the most professionally responsible course of action? Option A. Implement the temporary network adapter setting change and rely on a scheduled automated task to revert it later, assuming it will be handled without further oversight. Option B. Implement the temporary network adapter setting change without any documentation, as speed is paramount to restoring user access. Option C. Revert the system to a previous, known good configuration without documenting the temporary change that was considered. Option D. Implement the temporary network adapter setting change, meticulously document the exact modification and the rationale, and plan for its immediate removal once the issue is confirmed resolved. The correct answer is D. Implement the temporary network adapter setting change, meticulously document the exact modification and the rationale, and plan for its immediate removal once the issue is confirmed resolved. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the conflict between immediate operational needs and the long-term integrity of system configurations. The pressure to restore service quickly can lead to shortcuts that compromise established best practices and potentially introduce security vulnerabilities or performance degradation. The ethical dimension arises from the responsibility to maintain a stable and secure environment for users, even under duress. Careful judgment is required to balance the urgency of the situation with the adherence to established procedures and the principle of least privilege. Correct approach analysis. The correct approach involves meticulously documenting the temporary configuration change, including the exact parameters modified and the rationale for each change. This documentation is crucial for post-incident analysis, auditing, and ensuring that the system is reverted to its secure and optimal state. It upholds the principle of accountability and transparency, allowing for a thorough review of the incident and the actions taken. This aligns with the general principles of IT governance and operational excellence expected in a professional IT environment, ensuring that changes are controlled and auditable. Incorrect approaches analysis. One incorrect approach involves making the change without any documentation. This represents a significant regulatory and ethical failure. It bypasses audit trails, making it impossible to track the modification, understand its impact, or verify its removal. This lack of accountability can lead to security breaches going unnoticed and can violate compliance requirements that mandate change control and logging. Another incorrect approach is to revert the system to a previous, known good state without first documenting the temporary change. While seemingly a quick fix, this approach fails to capture the specific issue that necessitated the temporary change and the exact steps taken to resolve it. This hinders root cause analysis and prevents learning from the incident. It also risks leaving the system in a state that might not be optimal or secure in the long run, as the temporary fix might have masked underlying problems. A third incorrect approach is to implement the change and then assume it will be automatically reverted by a scheduled task without verification. This demonstrates a lack of diligence and an abdication of responsibility. It relies on an assumption rather than confirmed action, which can lead to persistent unauthorized or suboptimal configurations, creating security risks and operational inefficiencies. This violates the principle of due care and diligence in system administration. Professional reasoning. Professionals should approach such situations by first prioritizing immediate service restoration, while simultaneously adhering to change management principles. This involves a structured process. Assess the impact, plan the temporary change, execute with meticulous documentation, verify the resolution, and then meticulously plan and execute the rollback to the original, secure configuration. The decision-making framework should emphasize transparency, accountability, and adherence to established operational procedures, even under pressure. Question 20. The assessment process reveals that a junior administrator, in an effort to improve virtual machine boot times, has directly modified a critical XC host configuration file without following the documented change control procedures or obtaining prior approval. This modification was made outside of a scheduled maintenance window and has not been logged in the change management system. What is the most appropriate immediate action for the junior administrator to take? Option A. Immediately report the unauthorized configuration change to their direct manager and the IT security team. Option B. Continue to monitor the performance impact and only report the change if significant issues arise. Option C. Revert the configuration change to its original state and hope the unauthorized modification goes unnoticed. Option D. Proceed with documenting the change retrospectively and submit it for approval, hoping it will be accepted. The correct answer is A. Immediately report the unauthorized configuration change to their direct manager and the IT security team. Explanation. The assessment process reveals a scenario where a junior administrator, eager to impress, has implemented a change that, while seemingly beneficial for performance, bypasses established change control procedures. This presents a professional challenge because it pits the desire for immediate results against the critical need for documented, approved, and risk-assessed changes within a regulated IT environment. The core ethical dilemma lies in balancing operational efficiency with adherence to governance and security protocols. The correct approach, which involves immediately reporting the unauthorized change to the appropriate management and security teams, represents best professional practice. This aligns with the principles of accountability and transparency expected in IT operations. By promptly disclosing the deviation, the administrator allows for a controlled assessment of the actual risks, potential impacts, and the necessity of the change. This proactive disclosure upholds the integrity of the change management process, which is fundamental to maintaining a stable and secure VMware vSphere environment. It also demonstrates a commitment to following established governance frameworks, which are often implicitly or explicitly tied to compliance requirements in enterprise IT. An incorrect approach would be to attempt to fix the situation by reverting the change without reporting it. This is a regulatory and ethical failure because it conceals a procedural violation and prevents a proper risk assessment. The organization would remain unaware of a potentially destabilizing element in its infrastructure, and the underlying issue of bypassing change control would go unaddressed, increasing the likelihood of future, more severe incidents. Another incorrect approach would be to ignore the change and hope it goes unnoticed. This is a failure of professional responsibility and a direct violation of the principle of reporting deviations. It demonstrates a lack of integrity and a disregard for the established security and operational policies designed to protect the organization's assets. Finally, attempting to justify the change after the fact without prior approval is also an ethical lapse. It undermines the authority of the change management process and suggests a belief that individual judgment supersedes established organizational controls, which is a dangerous precedent in a regulated environment. Professionals should employ a decision-making framework that prioritizes adherence to established policies and procedures. When a deviation occurs, the immediate steps should be: 1. Identify the deviation. 2. Assess the immediate impact if possible and safe to do so. 3. Report the deviation to the designated authority or team. 4. Cooperate fully with the subsequent investigation and remediation efforts. This structured approach ensures that all incidents are handled transparently, allowing for informed decision-making and the continuous improvement of operational processes.